Hi there, this is an explanation of how to do example 13 for piecewise functions. Piecewise function is a function that is made up of pieces or parts. So rather than being one continuous function or a line, parabola or a line, it's some combination. So this example here has two lines together. You should recall that if you have two straight lines, there is only one xy coordinate pairing where the two lines are likely to overlap. Okay, so in this particular example here, they're asking you to find the function where y is 2x plus 1 for some value of x below a, and then y is 4x minus 1 for some value of x greater than a. So when I say below, I should have said less than, below or at a. So the first step to doing this is to find that overlap, or the point that occurs in both situations, which is a common x and a common y coordinate. So we need to use simultaneous equations to solve for what is that xy pairing. Now the book uses something called substitution. When I worked it through, it is actually substitution, but not obviously, and I'll show you why. Substitution is a method where you put one value of x or y into the other equation. All right, so you isolate x and then you put it into the second equation. So here's one way of doing this that I'm just going to take you through. With the first equation, 2x plus 1 equals y, I'm going to isolate x so it's by itself. So 2x equals y take 1, therefore x equals y take 1 divided by that 2. So I've now rearranged this using algebra to isolate the x. Second part of substitution, now I should have written substitution here as the method. Second part of substitution is to pop that into the other equation that you didn't use, and that equation is y is 4x take 1. So I'm going to drop that in. Y is 4 times this little beastie term, that's now our x term. So I'm just putting it straight in instead of that x there, take 1. A little bit of algebra to do here to unpack this. So y is equal to 4y, take 4 all over 2, take 1. So I've just expanded out this bracket. Next step would be to just break apart that half. So 4y over 2 minus 4 over 2 minus 1. And then after that, I'm going to just tidy that up. So 4y over 2 is 2y. Take away 2, take away 1 is what the y is. So it's a little messy, but what I want to do is I now have one equation with one unknown with y. So I'm just going to continue on to solve for y, which was the intention of doing all this anyway. So even up higher, up here, I have one equation with just y in it. Before I substituted, I had two equations with x and y. Then I substituted this thing into my second equation, and this second equation right here is an equation with just y terms in it, no x's, right? So we're working that through now. We're just solving for y right to the very end of this process. So what I'm going to do is put all the y's on the big side of y. So I'm going to leave that there, 2y. I'm going to take this y over and subtract it. And on the left-hand side, I'm going to move the remaining values. So it'll be 2 plus 1 goes to the left. So they change sides. So 3 is equal to 2y minus y, which is 1y. So now we've actually found that y equals 3. Now we're going to pop that back into either of the two equations to solve for what the x will be. This is all part of substitution, so I've got one absolute value for this. Let's pick an equation we're going to pop it back into. I'm going to put the 3 back into y equals 2x plus 1. I'll just choose the first equation. Both of them will do the trick. So the y equals 2 times 3 plus 1. So the corresponding y value is, sorry, let's just backtrack that, my bad. X isn't 3, y is 3. You hopefully saw that happening. So 3 is equal to 2x plus 1, and it's the x I need to find, okay, because y was 3, not x. Okay, so I'm just going to do my little trick where I switch the left and the right sides around, legitimately just rotating my equation about the equal sign. So 2x is equal to 3 minus 1, which is 2. And x is therefore equal to 2 over 2, which is 1. So now I have my points 1 and 3. That was quite a lot of steps to do the simultaneous equations, and it takes you back probably to last year. Another method that you might use for simultaneous equations, and I'm not sure, oh, that's a horrible line. I'm not sure if all of you were shown all of the methods for solving simultaneous equation, but that was substitution. So an alternate method is elimination, and elimination is of equations. Okay, so another way we could have come to that, and I'm just going to show you this method because it is an important mathematical method. What we do here is we line up the two equations. So we have 2y equals 4x plus 2. Okay, back. The reason I wrote that down is that our original equations are these: 2x plus 2 and 4x take 1. If we go ahead here and double this equation, we're just going to get kind of a doubled version of itself where the left and right sides are both doubled. So 2y is 4x plus 2. So I just multiplied 2 by each term in that equation, and I have a new equation which is a modified version of equation 1. I'm just going to call it 1 hash. The reason I did that is my second equation here has got twice as many x's as the first one had. So y equals 4x minus 1. So what I'm doing here is I'm going to line up these two equations, and I'm going to subtract one from the other because I've now made my x's exactly the same, and the x will disappear. So 2y minus y, so now I'm coming down in columns here, okay? I'm going to go 2y minus y is y, so I'm creating a new equation. 4x minus 4x is 0, nice and handy, so the x has gone. 2 minus 1 is like adding 1, so that's plus 3. So after doing that elimination of equations, I'm left with y equals 3. Exactly the same y as the previous method, and I can go ahead and substitute y into the other, y of 3 into the other equation, either of the two equations, to find x. So that's elimination. If you were to choose, now in my first substitution method, I chose to isolate x, but I could also have isolated y, so make y the subject in either equation. So let's get, and the third method for solving simultaneous equations is called, well, they actually call it substitution. So substitution 2, because they're substituting they're substituting y for this term 2x plus 1. So they're taking all this and they're putting it into the second equation, y equals 4x take 1. So we're just going to plop that all in there. So let's do it in blue. 2x plus 1, which is also y, is equal to 4x minus 1. So they're solving this through in the textbook example. They call it substitution, but what I like to think of this more plainly as is equating the two equations. So on the left we have equation number 1, and on the right we have equation number 2. And it's really just saying that y equals y. We want the same y, so we can just make those two equations equal to solve for x, okay? So we set y1 equals y2 because they are the same value, because we are actually looking for the points where x and y are the same, or the intersecting points, or the simultaneous ones. So we can call that whatever we like, but we're looking for a specific y, and that's when those two y's are equal. So remember, with straight lines, it's only one place that you can have the same y, where they belong to the same equation. So that's what we're doing here, and we can solve that out. So let me just do that through for you. 2x plus 1 equates to 4x minus 1. So basically we're just going to solve for x. I'm going to bring the x's to the left because I'll end up with a positive x, and take the number to the right. So I'm going to end up with 1 plus 1 is equal to 4x, take 2x. So 2 is equal to 2x, therefore, let's just flip that, 2x is 2, therefore x is equal to 2 over 2, which is 1. So this method's quite straightforward because you find the x first, and then you can plop it into either of the two equations. So let's just choose the first one. Y is 2x plus 1. We're going to substitute an x for 1 into there to find the corresponding y. So we solve that out. Y will equal 2 times 1, this guy, plus 1. So y equals 2 plus 1, which equals 3. Again, we found that the points of intersection of those two lines is 1 and 3. Okay, so no matter how we go about and find the points of intersections of the two lines, use that information to plot the two graphs onto one line. We know that this first equation here is relevant for values of less than a, less than or equal to, I think was the requirement, and the intersection point. Okay, that was little step 1. So remember that we have what we called a continuous piecewise. So continuous means that it runs through the two graphs where we have some value less than equal to a and some value greater than a. If it's continuous, a needs to be the same number that exists on both graphs. So that is where our x value is the simultaneous value of 1. And y was 3. So what we're going to do is we're just going to marker that out, 1 and 3 here. Just going to leave that there for a sec. And the next skill that you're going to need is to plot the two graphs on Cartesian plot. So just a reminder, when you do linear, we use the gradient intercept method. 2 is the gradient and the intercept is 1. So you can just do this stuff right on the graph. So the intercept is 1, 0, 1. So we put that point there, and then we use the gradient of 2 to mark out the second point. So we go 1 along, 2 up. You can do a further point if you want, 1 along, 2 up, 1 along, 2 up. So we are now starting to plot and plop that graph onto the graphing quadrants. I'm just going to go back this way too, 2 along, back 1, and so on. So this one here was the graph of 2x plus 1. I'm just going to label that. That's equal to y, of course. And so I've sketched that out. The second equation has a y-intercept at -1. So I'm just going to identify that point there. It's got a gradient of 4. So from that point, the next point over will be 1 along and 4 up. Okay. Yes, same point there, right? 1 along, 1, 2, 3, 4 up, and so on. You don't need to do many points. I'm just showing you this method for clarity more than anything. So I'm going to take a straight ruler here, and sketch out the red line. Now that graph there was y equals 4x take 1. I'm now going to sketch over the points that I sketched. I only need to do 2 points for a straight line. Okay, and that's that guy there. Now, the blue one was less than A, so less than the intersection point at x equals 1, y equals 3. So it's going to be everything, and I'm just going to use a highlighter so you can see. It's going to be everything here. Okay, so that's the function up to 1, 3. And then the function past that is identified by the second equation, red line here. So if you look at your book, they redraw this with just those 2 lines nice and straight. So what I'm going to do, mine's a bit ugly, but ugly can be mathematical if we just kind of account for that. So what I'm going to do here is I'm going to just label the entire function as y equals 2x plus 1, where x is less than or equal to 1. And y is also 4x take 1, where x is greater than or not equal to, just greater than 1. It could be the same, but that's kind of smooth. So the top one includes the 1, this one doesn't. But that makes it all continuous, if you know what I mean, okay? So it's up to and including the dot here, and then beyond that when we use the second equation to identify it. So we're just being respectful to the way that it's laid out. I hope that helps. I'm just going to run through the further examples with you, giving you a little bit more information than you need to help you put the skills together for piecewise functions. All right, peace out now, guys.